Levitation is the process by which an object is suspended by a physical force against gravity, in a stable position without solid physical contact. A number of different techniques have been developed to levitate matter, including the aerodynamic, magnetic, acoustic, electromagnetic, electrostatic, gas film, and optical levitation methods. Physics. For levitation on Earth, first, a force is required directed vertically upwards and equal to the gravitational force. Second, for any small displacement of the levitating object, a returning force should appear to stabilize it. The stable levitation can be naturally achieved by, for example, magnetic or aerodynamic forces. Levitation techniques are useful tools in physics research. For example, levitation methods are useful for high-temperature melt property studies because they eliminate the problem of reaction with containers and allow deep undercooling of melts. The containerless conditions may be obtained by opposing gravity with a levitation force, or by allowing an entire experiment to freefall. Magnetic levitation. Although any electromagnetic force could be used to counteract gravity, magnetic levitation is the most common. Diamagnetic materials are commonly used for demonstration purposes. In this case, the returning force appears from the interaction with the screening currents. For example, a superconducting sample, which can be considered either as a perfect diamagnet or an ideally hard superconductor, easily levitates in an ambient external magnetic field. The superconductor is first heated strongly, then cooled with liquid nitrogen to levitate on top of a diamagnet. In very strong magnetic field, by means of diamagnetic levitation, even small live animals have been levitated. It is possible to levitate pyrolytic graphite by placing thin squares of it above 4 cube magnets with the north poles forming one diagonal and south poles forming the other diagonal. Magnetic levitation is in development for use for transportation systems. For example, the Maglev transportation includes trains that are levitated by a very large number of magnets and, due to the lack of friction on guide rails, they are potentially faster, quieter and smoother than wheeled mass transit systems. Other levitation methods, a number of different techniques, that don't involve magnetism, have been developed and are commonly used to produce the stable levitation of matter. These methods are discussed below. Electrostatic. In electrostatic levitation, an electric field is used to counteract gravitational force. Aerodynamic. In aerodynamic levitation, the levitation is achieved by floating the object on a stream of gas either produced by the object or acting on the object. For example, a ping-pong ball can be levitated with a stream of air from a vacuum cleaner set on blow. With enough thrust, very large objects can be levitated using this method. Hovercrafts, however, do not use powerful down thrusts to achieve stable levitation but instead rely on producing a region of high pressure underneath them. Acoustic. Acoustic levitation uses sound waves to provide a levitating force. Gas film. This technique enables the levitation of an object against gravitational force by floating on a thin gas film formed by gas flow through a porous membrane. A common example of this is air hockey, where the puck is lifted by a thin layer of air. Optical. Optical levitation is a technique in which a material is levitated against the downward force of gravity by an upward force stemming from photon momentum transfer. Casimir force. Scientists have discovered a way of levitating ultra-small objects by manipulating the so-called Casimir force, which normally causes objects to stick together due to forces predicted by quantum field theory. This is, however, only possible for micro-objects. Buoyant levitation. Gases at high pressure can have a density exceeding that of some solids. Thus they can be used to levitate solid objects through buoyancy. Noble gases are preferred for their non-reactivity. Xenon is the densest non-radioactive noble gas, at 5.894 grams per liter. Xenon has been used to levitate polyethylene, at a pressure of 154 atmospheres, uses animal levitation. Scientists have levitated frogs, grasshoppers, and mice by means of powerful electromagnets utilizing superconductors, producing diamagnetic repulsion of body water. The mice acted confused at first, but adapted to the levitation after approximately 4 hours. suffering no immediate ill effects. Maglev trains. Magnetic levitation is used to suspend trains without touching the track. This permits very high speeds, and greatly reduces the maintenance requirements for tracks and vehicles, as little wear then occurs. This also means there is no friction, so the only force acting against it is air resistance. Further reading, Charles P. Strelo, M.C. Sullivan. A Classroom Demonstration of Levitation. ARZIV, 0803.3090, see also, Anti-Gravity, Flight, Weightlessness, References. External links, the dictionary definition of levitation at Wiktionary, Diamagnetic levitation.